Good day, students. Let's continue our discussion on the concentration units for solution. But before that, let's have a recall first on the previous discussion about the formula discussed on percent WW, percent V over V, and percent W over V. So as you know, the formula are as follows for percent by mass, percent by volume, and percent by mass and volume. So please correct that one over percent W over V. So with that, with those formula, let's have a rapid solving. I would like you to prepare your calculators and answer the following word problems as fast as you can using the um, previously shown formulas. Okay? First problem, you can pause this video and try to answer this problem. So what is the mass percent concentration of a solution made by adding 21.4 grams of sodium chloride to 135 grams of water? In this problem, let's analyze what is the solute and what is the solvent. So obviously, the solute is the NaCl and the solvent is the water. So using the formula for mass percent, 21.4 grams divided by the total grams or mass of the solute and solvent. So we have to add 21.4 and 135. So the final answer is 13.68%. Next, we have to calculate the percent mass volume of a 762.5 milliliter solution that is prepared by dissolving 289.15 grams of calcium azide in water. Your answer here is 37.92%, and that is because we just have to divide 289.15 grams over 762.5 milliliters of solution. Next problem, what is the amount in grams of hydrogen peroxide needed to make a 6 kilogram on 3% by mass of hydrogen peroxide solution? So in this problem, we should be able to use the percent by mass formula. So given that we already have the percentage here, so remember, if we have the percentage, so that is the one included on the left side of the equation. So this will be, let me write something on here. So 3% is equal to the unknown, which is the amount of grams or the amount of substance or solute. Ayan, in grams. So let's put X on there on that one. Divided by 6 kilograms. So it should be in grams. So 6 kilogram equivalent to grams is 6,000 grams times 100. Now, if we will be having this 3% into decimal, remember, we also have to make in decimal the 100 here. So in decimal, 3% is 0.03 and 100% is equivalent to 1. So you just have to cancel that out. And then cross multiply 6,000 into 0.03. And our answer should be 180 grams. So remember, if you would like in your calculator to use the percentage, on the other side, it should also have a percentage on 100. Okay? Ayan. All right. So next problem, let's have the percent volume by volume of a solution by adding 38.2 milliliters of ethanol to enough water to make 250 ml of solution. So in this problem, all we have to do is to substitute the values for the percent by volume formula. So that will be 38.2 milliliters divided by 250 milliliters, which is equal to a 15.28%. So how many of those questions were you able to answer correctly? I hope it's 4 over 4. If you are still confused with that, part of the lesson. So please do some practice exercise on this problem. Okay? Now, let's proceed with the discussion on the fourth one on the concentration units, which is the mole fraction. So mole fraction, the way that we solve this one is somehow similar with how we solved the previous lesson on Dalton's partial pressure. And in this one, a mole fraction has a symbol of letter X, small letter X, or big letter X, either of the two. And this one that you can see on the formula on the slide. So we have here we have here the X sub A. So the A here as the subscript can be either of the two substances that we have in the solution. So it's either X sub solute or X sub solvent. So those are the two substances that we would like to analyze on each problem. So if your A here is the solute, so your B here will be your solvent. So you have to add the total. This is total, right? Total mole of the substance. So take note that the fraction of the solvent and solute that you are looking for is in moles. So remember, we have the formula for getting the moles should be mass over molar mass. And this will be used later on our solving in mole fraction. So please remember that one. And this equation that you can see on the lower portion of the slide, the x sub a plus x sub b is just for checking because your solute and solvent, once you have computed it at the end, you will have to check if it's equal to 1 to check if it's really correct. So your final answers should always be, the sum of it should always be equal to 1. All right? Okay, now let's try to um, apply this one on a certain problem. So the way that we solve for mole fraction is just simple. It's just that you have to be careful and most especially, excuse me, if your given is in grams because we cannot directly use that not to solve the problem. So in this sample problem that we have, 25 grams of sodium fluoride is mixed with 200 grams of water. What is the mole fraction of NaF in the solution? So step number 1 using the GRESA method is to identify what is the solute and the solvent in this problem. So the solute in this problem is obviously the lesser one, and that is 25 grams of NaF. So that will be our solute. And our solvent will be the 200 grams of water. Now, we need to find the mole fraction of NaF. And NaF is the solute, so we can have the symbol for the X as the mole fraction as either NaF or X solute. Yan. So we can use that one later on. Okay, so let's have on the next slide so we can write the step-by-step process. So remember, we already have the given as follows. So 25 grams of NaF, that's the solute. Let me just write it down here. And this one, 200 grams is the solvent. Now, our formula in getting the mole fraction. So, sige, let me write it down here so I can show you the specifics. So, this is the solute and this is the solvent, 200 grams of water. So, we need to find X solute or the XNaF. Okay? Now, the formula or the equation for getting the mole fraction of NaF is equivalent to the mole of the substance. So that word substance can be changed into the formula, the chemical formula that we are using. So mole of NaF all over the total moles of the solution. All right. Now, my question is, can we directly use the given in this formula? The answer is no, because our given is in grams, which is a unit for mass, right? So this is for mass in given, and we need to find the mole. So remember our triangle earlier? So we have the mole on the side, molar mass, and then the mass. So we need a lot of effort to convert our given into moles first before we use that on the equation. Now, let's first have the 25 grams of NaF, and let's try to solve for the number of moles of this one. So in order to do that, so covering up this one, so it's mass divided by molar mass. So how do we get the molar mass of the substance? It's by looking on your periodic table and then checking on each of the elements in the compound, and then check their specific numbers or the atomic masses, no? Now, for sodium, you will see there, sodium has 22.99 grams per mole on your periodic table. So check your periodic tables with you. Now, you have to add for fluorine. So what is the, what do you call this? The atomic mass for fluorine. So it is 19.99, right? Let me check on that. Or about 18 rather. 18.99 grams per mole. Now, you have to add the total. This is a Gen Chem 1 lesson, no? So you have to add 18.99 plus 22.99, and that is equal to 41.98 grams per mole. Now, this is not yet the moles because this is the molar mass of the NaF. Now, how do we get the moles? So again, going back to the triangle, it's mass divided by the molar mass. So NaF here is equal to, get the given, 25 grams of NaF divided by all over 41.98 grams per mole. So that will be 41.98, 0.595, or we can simply put on 0.60 moles here because we have to cancel out grams, and this is the mole of NaF that we can later substitute here on the side. Now, since on the denominator, we have to look for the total moles of the solution, of course, it's not only the moles of NaF that we need to get. We also need to get the number of moles of the 200 grams water here. So what is the molar mass of water? Hydrogen is 1.008 and oxygen is 16. So that is approximately 18 grams per mole. Now do the same thing that we did here or earlier. So we need to divide 200 grams water all over 18 grams per mole. And how much is that? So 200 grams divided by 18 grams per mole is 11.11 moles of water. Cancel out grams here to get the moles of the water. So this one and this one will be both into the total moles. So you have to add them later on. Okay? Now, for our solution, we can now directly substitute the values here on this one. So we have now the mole of NaF, which is equivalent to 0.60 mole of NaF divided by all over the total moles. So the total moles is 0.60 plus, we have to write there the mole plus 11.11 mole of water. So that will be 11.71, right? So this one is the total mole of the solution. All right. Now, substituting the values, rather putting it on your calculator, 0.60 divided by 11.71 is equivalent to 0.05. So the the mole fraction of NaF is 0.05. So that is our answer to this problem. Now, to double check if your your solute and solvent is really equivalent to 1, we need to make use of this formula, but we'll be changing it to water for solvent. So it's X H2O is equal to, let me erase this one first. Okay. So that will be, the mole of water divided by the total moles of the solution. So it will be, the mole of the water is 11.11 mole divided by 11.71 because this is the total mole of the solution earlier. Just have to add this two. And your final answer for the mole fraction of water is 0.95. So remember that there are no units for mole fraction because this just show the fraction of the solute and solvent. So it's 0.5 plus 0.95 is equivalent to 1. So that is how we get the mole fraction in this problem. All right. Now, on this slide, you will see the step-by-step process. So you just can go back to the step-by-step process that we did and replay that and do practice exercise later. So this is, let's check if our answers are correct. So these are the formula and we just have the conversion. All right, it's already 42 grams mole here. So let's go on to the final answer, which is, this one is the total moles of the solution. And the final answer is correct, 0.05 mole fraction of the solute and 0.95 mole fraction for the solvent. All right, now you pause this video and try to solve for this problem number 1. And the final answer here is, let's see. All right. So in this problem, we need to get the both of the mole fraction of water and ethanol in the solution. So we just have to do the all over the step-by-step process that we did on the first problem. But in this case, you need to again convert the grams of ethanol and grams of water into moles before you proceed on getting the mole fractions of the solute and the solvent. So the final answer here should be 0.14 144 or 0.15 can be and 0.85. Now, let's proceed with the next of the concentration unit, which is molarity. And molarity is defined as the amount of the solute in moles per volume of the solution. So the unit of measurement for molarity is either capital letter M, and that capital letter M can also be equivalent to mole over liters. So remember, the volume should be in liters and the amount of substance should be in mole. Liters, not ml. So if we see on a problem, milliliters, we have to change or convert that into liters. Let's apply it on a simple problem. What is the concentration of the solution with 10 moles of HCl or hydrochloric acid that was added to 2 liters of solution? So this is direct substitution. So it's just 10 over 2 liters. So that is 5 moles per liters in molarity. Let's apply this one on a more complicated one. Not that complicated, but you just need to have a lot of conversion factors here. So, in this case, what is the concentration of 10 grams of NaCl that was added to 140 ml of water? So, our given here is, let me write it down here. So, our given here is, our solute, of course, is 10 grams of NaCl. And our solvent is 140 ml of water. And since our formula, let me write here first, the required is in molarity and mole per liter, that's slash. Our equation is molarity is equal to the amount or the moles of the substance, okay, or the solute, let's write it down there, over the volume of the solvent. It's solvent, ha, not solution. Now, our solution here is that we cannot directly substitute the value here because it's in grams. So we have to check, or we have to convert again 10 grams of NaCl towards moles. And how do we do that? The same process we did earlier. So the molar mass of NaCl is, let me just go on and shortcut this one, ha, because the molar mass can be found, you know how to get the molar mass by multiplying or by adding the total atomic masses. So it's 58.44, right? Okay. And you need to divide this grams per mole all over the given of 10 grams. So 10 grams divided by 10 grams divided by 58.44 is equal to 0.17 mole. So we have to cancel out the grams here. Now, this 0.17 can now go directly on the problem. But first, let's convert 140 into liters. How many? That is 0.14 liters. So substitute the values. We have 0.17 mole all over 0.14 liter, and that is equivalent to 1.21. What's the unit of measurement for molarity? It's either capital letter M, or just copy this one because you cannot cancel anything that on that. Mole per liter. So 1.21 mole per liter is the final answer. Let's see if that's correct on the slide. So it's 1.22 here, a little bit of um discrepancy, but that's fine. No, it's 0.01 per lang. So, pause and try this problem and try to answer how many grams of potassium hydroxide are there in 500 ml of 0.350 molarity of potassium solution. In this problem, as you can see, the molarity is already given, so you have to do the other way around process on this problem. So let's see how do we do that. So you can directly substitute the values and then solve for it. And you will see here that the volume in is converted first into liters because we have 500 ml there. So in liters, that's 0.5 liters. And afterwards, the mole is multiplied, or the mole over liter is multiplied to 0.05 there. And as we can get, the amount of mole is 0.175 mole. And the mass of the solute, which is the unknown, will get that because we need to what? We need to convert the mass of the solute. We need to get the mass of the solute by multiplying 1.75, which we got from the formula, multiply by 56.11, which is the molar mass of potassium hydroxide. So we multiplied it because in our triangle again, to get the mass, multiply the mole and the molar mass. Okay, so this one is that. So the final answer is 9.82 grams of potassium hydroxide. Did you get it correctly? All right. So, and this one, you can skip this problem because this is somehow similar on the third one. Lastly, we have molality. So molality is different for molarity. The letter R and L is different there. And molality has a symbol of small letter M and has a unit of measurement of mole per kilogram. So remember, This time, it's not liters, rather it's kilogram and not grams. Okay? Now, let's apply this one on a certain problem. Here we have to calculate the molarity of the solution containing 16.5 grams of dissolved naphthalene in 0.0543 kilograms of benzene or C6H6. In this case, again, the formula or the first step is to identify first the given. So what is the solute here in this problem? The solute usually is the one that is being dissolved. So if we have dissolved naphthalene, obviously, naphthalene will be the one that is the solute. So we have 16.5 grams of C10H8 and the solvent is 0.0543 kilograms of benzene C6H6. All right. Now we have to find the molality in small letter m, and we can get that by dividing the mole of the substance all over the kilogram of the substance. Now, we cannot directly input the 16 point grams here because it's in grams and we need to convert that first into moles. So first is to get the molar mass of C10H8. What's the molar mass? Let me write it down directly already. So carbon is on your periodic table is 12. So times 10, that's 120. And then 8 hydrogen. So approximately that is 128.17 grams per mole. Now, divide this one with 16.5 grams of C10H8. So you will get the amount of moles of the naphthalene, which is equivalent to 16.5 divided by 128.17 is equal to 0.128 0.128 moles. Now, cancel out grams here and then we can now directly substitute the values. So 0.128 mole of naphthalene divided by the kilograms of benzene, which is 0.0543, no conversions needed, kilogram of C6H6. So that will be equivalent to, on your calculators, please, 2.37 or 2.3071 mole per kilogram. So this is our final answer for this. All right. So you can go back on the step-by-step process that was written here on the slide and try to do this problem, pause the problem, and check on if you will get the same answer on the final slide. Now, on this part, you can do a practice exercise on your textbook, page 35 and page 37, practice exercises 2.1 and 2.3. So you'll be ready for the written work next week. Thank you.